Every single app you use, every website you visit, there's this hidden blueprint that keeps it all from falling apart. Well, that blueprint, that's IT architecture. And today, we're going to demystify it. So let's just jump right in.
So this is really the #1 question every architect has to answer. I mean, in a world that completely runs on digital services, how do you build something that's reliable, secure, and can grow? It's a huge challenge, because if you get it wrong, the whole thing can just come crashing down.
And just think about it for a second. Today's IT is, well, it's a maze, right? You've got virtual machines, containers, all these cloud services, and a million different pieces all trying to talk to each other. It's just pure complexity. Architecture is what gives us the map. It's the structure and clarity we absolutely need to find our way through without getting totally lost.
All right, so how do you even start to understand a system that complex? Well, here's the thing. You can't look at it all at once. That'd be impossible. It's kind of like trying to build a skyscraper from just one single drawing. It just doesn't work. Instead, architects use a few different views or lenses to zoom in on specific parts of the design.
And these are the 4 big ones, the essential lenses they use. It's a process, right? They start way up high with the big picture conceptual view. Then they zoom in a bit to the logical view, which is like the floor plan. From there, it's time to get into the weeds with the physical engineering schematics, the real nuts and bolts. And finally, they bring it all together in the solution view, the final master plan.
Okay, this table really breaks it down and makes it all make sense. The conceptual view, that's just the why. We're building a landmark office tower. Simple as that. The logical view gets into the what. It's the floor plans, showing how all the rooms and offices connect. Then you get to the physical view, the how. This is the nitty-gritty, the schematics for the steel, the concrete, the wiring, and the solution view, that's everything. It's the complete master blueprint, tying the vision all the way down to the materials you're going to use.
So we've got these different views, these lenses. But how do we actually use them to design systems in the modern world? Because let me tell you, the whole philosophy has changed. It's been a fundamental shift, moving away from old, rigid ways of doing things to something way more dynamic.
And this quote just perfectly captures that shift. In the past, we treated servers like pets. Now, we treat them like cattle. This is probably one of the most powerful and important analogies in all of modern IT. It forces you to completely rethink how you manage systems, moving from these cherished, unique servers to a much more industrial, automated approach.
So what does that actually mean, pets versus cattle? Well, pets are those special, hand-built servers. You know the ones. You give them a unique name, you take care of them, you patch them. If one gets sick, you spend days, maybe weeks, nursing it back to health. Cattle, on the other hand, are totally different. They're identical, they're automated. If one of them fails, you don't even think about repairing it. It's just gone. And a new, healthy one automatically takes its place. This mindset is the absolute core of modern cloud-native design.
Okay, so how do you build an application like a herd of cattle? The big answer here is microservices. See, instead of building one giant monolithic application, which is like a single big pet, we break it down into a collection of small, independent services. The beauty of this is that each little service can be scaled or updated or replaced all on its own without bringing the whole system down. Now, is it more complex to manage hundreds of tiny services than one big one? Yeah, for sure. But the resilience and flexibility you get in return, it's almost always worth it.
All right, so we've got the blueprints and we've got the design patterns. Now let's talk about the raw materials. What are the actual technologies we use to bring these architectures to life?
First up, let's talk about the brains of the operation, compute. This all really starts with something called a hypervisor. Think of it like a magic layer of software that lets us take one big physical server and slice it up into lots of smaller, independent virtual machines, or VMs. Then we group these physical servers into clusters to get more power and, really importantly, more resilience. And this setup lets us do incredible things, like vMotion, which is literally moving a running application from one physical machine to another with absolutely zero downtime. The user has no idea it even happened. So cool.
Next up is the system's memory, which is storage. In a modern setup, your data isn't just stuck on one single server. That would be way too risky. Instead, it lives on shared storage, which means the entire cluster can get to it. This makes the whole system so much more flexible and resilient. We organize all this data into what we call data stores, and then we use these really smart storage policies to automatically manage everything, like how it's protected and how fast it needs to be.
And finally, we've got the nervous system that connects everything together, the network.
On the physical side, modern networks use designs like leaf-spine to be incredibly scalable and resilient. But honestly, the real magic happens in the virtual world. With things like a distributed switch and software-defined networking, or NSX, we can manage the entire network, all the switches, routers, firewalls, completely in software. We can create them and tear them down on the fly, managing and securing the whole system from one central place. It's a game changer.
Okay, so we have the plans, we have the patterns, we have the raw materials. But why? Why do we go through all this trouble? It's not just about playing with cool tech. It's about delivering on the promises we make to the business, and ultimately to the people using the system. And that brings us to a really critical idea: non-functional requirements, or NFRs for short. These aren't about what a system does, but how well it does it. Think about it like this. It's one thing to build a skyscraper that has offices and windows. That's the functional part. But it's another thing entirely to make sure that skyscraper is earthquake-proof, that it has fire suppression, that it's secure. Those are the NFRs. And a failure in one of those isn't just a bug, it's a complete catastrophe.
And as you can see here, a great architecture is all about finding the right balance. It has to guarantee the system is available. That it's actually up and running when you need it. It has to perform well, so it's fast and responsive. It needs to be able to scale to handle more and more users without falling over. Of course, it has to be secure from all kinds of threats. And finally, it has to be manageable for the poor folks who have to run it day in and day out. If you fail in any one of these areas, the entire design is pretty much a failure. So as we wrap this up, I want to leave you with this one question to think about. When you look at the digital world around you, the services you depend on every day, are they built like fragile, one-of-a-kind pets, or are they designed as a resilient, self-healing herd of cattle? Because really, the answer to that question tells you everything you need to know about modern IT architecture.